For this problem, a charity organization had to sell a few tickets to their fundraiser just to cover necessary production costs. After selling 10 tickets, they were still at a net loss of $800 due to the production cost, and they sold each ticket for $70. So we need to define our variables first. We're going to say Y represents the net profit in dollars. So Y is the profit. And again, our units are going to be dollars here. And then X is the number of tickets. So I'll just write number of tickets for that. And we need to complete the equation between that net profit and the number of tickets sold. So we've defined our variables. Now the next step in our strategy is to start looking for those key pieces of information. So basically, what are the numbers in the problem here? And so this second sentence here, after selling 10 tickets, so let me write this down and let's just make a little bit more room. So when X is 10, so we've sold 10 tickets, Y is the net profit, but we're at a loss of $800. So if your profit's at a loss, that means you're minus $800. Well, really, we don't need to put the units, we know what they are. So minus 800 is our Y value there. And we also know that they sold each ticket for $70. So it's $70 per ticket. That is a rate right there. So this is actually our slope. And so we can write that down. So that $70 per ticket, this is our slope. And at this point, since we've found our key information, we just need to use our slope-intercept form. So in other words, we need to figure out what our slope and our y-intercept are. Or you could also use point-slope form because we do have a point and we have the slope. So actually at this point, you can just plug those straight in. And I'll show you an example like that, and then I'll show you the other method if you'd prefer to just find the y-intercept. So point-slope, remember, let me just write it down for you, is y minus y1 equals m times x minus x1, where this line goes through with a slope of m and through the point x1, y1. So whenever you have the slope and a point, you can just plug them in here. So we can call this x1 and this is y1. So y minus y1, which is negative 800. So we're actually going to be adding 800 because when you subtract a negative, it's the same as adding. Our slope is 70. And then multiplied by x minus x1, which is 10. And from here, you should just solve and simplify this equation to get it as y equals something. So you still got to do a little bit of algebra here, but it's not too bad. We're first just going to distribute this. So y plus 800, the 70 goes to both of those. You get 70x minus 700. Then we're going to subtract 800 from each side. So what we get is that y is 70x minus 1500. Let me just make a little room there. So this is what we think the equation is based off our point-slope form. But as I said, let me show you the other method so that you have two different options. And really, you can do it however you want. So the other method, we're still going to use this information. Let me just write down that info. So we know m is 70. And we know it goes through the point 10 comma minus 800. So we need to find the y-intercept. So let's first revisit our slope-intercept form. We know b is the value that we need to find. And we know m is 70, so I'm just going to replace that. So y is 70x plus b. And we can use this particular point to figure out what b is. Since this is our x value and this is our y value, we can just plug those in, and then we have an equation where we're just missing b. So let's do that. We have minus 800 equals 70 times 10 plus b. So this is going to be 700, and we need to move that to the other side so that we get b by itself. So we will subtract 700 on each side, and you get that minus 1500, which you'll see is exactly what we got using the point-slope method. So both ways get the same answer, and frankly, that's a way to check your work. If both methods get the same answer, you can feel pretty good about it. Now, we also want to make sense of our equation based off the information they gave us. So let me just rewrite the equation in here. Y is 70x minus 1500. And so they sold each ticket for $70. Well, every time x increases by 1, you're essentially adding another 70. So that makes sense. If you put in 3 here, selling 3 tickets, you'd make $210. But we also have this big production cost. So now let's check this other data point. After 10 tickets, they still had $800 in loss. So 70 times 10, if you plug that in, is 700 minus 1500, which would be that loss of $800. So we checked our work with the information that was given to us, and the equation made sense. So we can feel good that this is the correct answer. So let's keep going with these. In this one, we have Addison, who painted her room. She had 50 square meters to paint, and she painted at a constant rate. So she had 50 square meters to paint. That's what she's starting with. And we have this data point. After 2 hours of painting, she had 35 square meters left. So first step, as always, define your variables. Y is the area, and this time it's in square meters. So Y is our area, and I'm just going to put meters squared there. And then let Y represent the area left to paint after X hours. So X, again, is time, and the units are hours for this. So we've defined our variables. Now we want to look for key pieces of information. So the second sentence, she had 50 square meters to paint. So what we can learn from that is that when X is 0, so before she started painting, she had 50 square meters to paint. So Y in this case would be 50. So that is our Y-intercept. So we can just call that B from, remember, our slope-intercept form, since ultimately this is what we're trying to find. So we found B already. And after 2 hours of painting, she had 35 square meters left. So that's another data point. That's a point on this line. So when X is 2, so 2 hours, she still had 35 square meters left. And I should be careful here, because Y, it's not actually the area. It's the area left to paint. So I have to be careful there, because we're actually subtracting that area. We're not painting more and more area, so Y is not increasing. Y is actually decreasing, because slowly she's going to paint more and more of that wall or of her room. So back to this data point, after 2 hours of painting, she had 35 square meters left. So in this case, Y is 35. And we know B, but we don't know our slope. So that's what we have to find. And we'll use our slope formula. M is Y2 minus Y1 over X2 minus X1. So we plug in our numbers. This can be X2 and Y2. This can be X1 and Y1. So we get that M is Y2, so 35 minus Y1 of 50 over X2, which is 2, minus 0 for X1. So this would be minus 15 over 2. Or if you'd prefer, you can make it minus 7.5. And again, this is a rate. Since it's the slope, this is going to be square meters per hour. And it should make sense to you that this is negative, because we started with 50 that had to be painted, and we're slowly subtracting that. So we are losing 7.5 square meters every hour that needs to be painted. Or another way to look at it is that Addison paints 7.5 square meters per hour. But since we defined Y as the area left to paint, instead of the area that has been painted, our slope is negative. If it was the area that has been painted, our slope would be positive. So we found our slope, we found our Y-intercept, we can just plug those in. So Y would be minus 7.5x plus 50. And let's make sense of this based on our data. We know that when X is 0, when no painting has been done, that our Y value would be 50. There would be 50 square meters left to paint, so that piece makes sense here. And the second data point after 2 hours, so we're going to plug that in here. So you get minus 7.5 times 2, which is minus 15. Minus 15 plus 50 is 35. So when you plug in at 2 hours, you do get back that there's still 35 square meters left to paint. And since all of that worked out, since this makes sense with our data, we know for sure that this is the right equation.